I'm CK. Today we've got a module from DivKid and Making Sound Machines. It's their DivSkip. It is a trigger clock manipulator. Does all kinds of things to input clock signals, to split them, change them, modify them, send them out twice per channel, or same channel going out two outputs. It's got some muting, and what else does it have? Push to mute, 8 modes per channel, and nice LED rings that'll light up to make your rig look fancier in the club. So we'll put it together, put it in the rack, see how it does in manipulating clocks, and I hope you enjoy the video. The box, nice enough box, as is typical. I picked this up from thonk.co.uk. It was packed in Dusseldorf, Germany. And on the back, manufactured by Making Sound Machines, and so on. So let's see what's in it. I don't know how much soldering we're going to be doing on this one. It might be a lot of pre-installed. Okay, here's all the stuff to do with it, which is pretty cool, but we'll look at that later. Let's try and find the front panel and the circuit board. And these are in here, so we have to cut it apart. So we've got a knob, a knob, a knob, a knob for the 4 channels, and it looks like we've got, that looks like trigger versus pulse, and M1 and M2, I don't know what that means. So we've got CV that can affect those things on each channel, and we've got 1, 2, 3, 4 inputs, and for each input we've got 2 outputs, which is nice. And as you can see, there's some translucency here, even though where the LEDs actually are, that's completely cut out. Now, as I went around to look at that, the other side has different stuff. It has more text on it in case, so you don't necessarily have to bring the manual with you. So this is probability CV for whether it's going to let a gate through or not, or whatever else they have set up for the 8 modes. Trigger input and trigger output. So a little clearer on that end. Here we've got the main circuit board. Looks like it's got a USB-C connector here, which probably is to program it if you want. There's a reset button, looks like, a couple of pin headers, that's probably for something I'll show you in a second. That looks like where the power is going in, pots and jacks, and there's a whole bunch of surface mount already installed. I got to check these because occasionally when you get a kit, the electrolytic pots, because they stick up, can get knocked loose, but these look fine. And on the back, DivKid and Making Sound Machines, DivSkip, Rev E, July 2024. And this is a boot button, if you have to reboot it, I believe. Because we also have in here, we have this fella. Oh, I see what this is. This is, I thought it was a daughter board, it's not. So all the logic is here. This is the LEDs that will go behind the front panel, like so. So just a ring of LEDs all the way up. Now there are 2 unfilled solder junctions there, jumpers, and these pins are what go in the pin headers that I showed you a minute ago, here and here. And again on the back there are 2 jumpers that are not put together. Rev B, March 2024. It's got 2 little, almost looks like dust rings. Maybe it's for these to give a little more space to adjust it so it fits snugly up against the front. Again, I'm just speculating there. Then we've got a backing plate, which I assume is going to go here. Yeah, it's going to go here behind there, and it's got an arrow showing up. So I'm not sure why this is here, unless it's just to make the jacks snug up a little bit better. And we've got a little DivSkip metal thing and a DivKid sticker, which I'll put on my sticker wall. Let me get a parts tray for the actual bits and pieces that we will be working on. And I don't know, I didn't see a build guide reference, but I'm sure there is something here because I'm on their website. Here it is, DIY build guide. So we've got a couple of knobs. They're simple press-on knobs, but at least they do have a little wedge cut out so you can get them aligned without fighting. And again, the pots have the little cutout on their shafts. A couple of switches. Again, we have to, I don't know what M1 and M2 are. Maybe it's mode. I'm going to make an assumption that it's mode, but we'll see that later. Let me see what's in here. That's a voltage regulator, I believe. Okay. And in the other bag, just all the jacks, and thankfully they took all the panel nuts off before they packed it, which I appreciate. And a power cord. Let me take a look at anything else in here I want to take a look at. So it looks like it's going to be a really quick build. I'm comparing they have a nice picture of all the parts you should have. That's pretty cool. Some tools you need. Here's the kit. Lots of good pictures. And very, very step-by-step directions. Oh, that's a 3.3 volt power brick. That's what that is. So that voltage regulator is going to take, I don't know whether it's taking the 12 volt or taking the 5 volt and stepping it down, but it'll go in here. And what can I see? I'm trying to see if I can follow the traces, but it's a little complicated. No, I can't follow the traces necessarily. Okay. And then I want to see what we're going to do with the plastic sheeting. Okay, yeah, we are, as I thought. We're going to set the plastic sheet across the top of the jacks. And that's okay. And yeah, the little white rectangles in with the LEDs do go on the connector as a little spacer. So it's going to be a very quick kit to put together. Let's see, what is this? Oh, I see what that is. I was wondering what, where did I put it? Where did I put it? Oh, these are adhesives to stick oh, I see what they're doing. So this is an adhesive that's going to go between on the, I'm not quite sure where it's going to go. So you're sticking that to the panel? That doesn't make any sense, does it? It's not translucent. Oh, we'll figure that out when we get to it. And again, tons and tons of photos and then some test stuff. Oh, how do we mute this actually? Oh, these are encoders, they're not pots. So they're encoders, so they're pushable. You might be able to hear that click, click, click. And that allows you to mute or unmute a channel, which is really nice. Okay, good. So we'll get the soldering iron heated up and put this thing together. And I was just about to say, let's go ahead and put this thing together, and I realized I had the wrong soldering bit on. I was building a guitar amp, and I was using my heavier bit. So we'll take it off and put my normal thinner bit for electronics. Of course I had turned it on, so it's really hot right now, but I don't care. I've burnt myself so many times in my life, I barely notice. So we'll put my regular 30 degree, let me make sure it's set right, it is. Put my regular 0.03 or 0.30, whatever, 30 degree bent bit on. And now we'll go ahead and put this thing together. We will start with the power header, as the build guide guides us, and it does have a keyway to get it right, and there's a little gap there showing where the keyway is. However, because we are very paranoid, there's also a indication of where the red line goes, and I'm going to just set this in. So that's not right. I mean, I'm looking at the picture. The cutout on the header should face making, which is what it's doing, but it says red here. That usually means that that's where the red stripe should be. And yes, it does go that way. Okay, I'm sorry, I confused myself. Yes, that is the right way that it goes. So we will solder one pin, making sure we don't touch any of the surface mount components that are already installed with our soldering iron. Solder one pin, take a look, make sure it's flat, and it is, and we'll get the rest of the pins. And that is on. Now we'll put the voltage regulator on. Where is it? Where'd it go? There it is. And it fits right inside the white outline they've made on the board, so you know how to align it properly. And again, I'm going to do one pin because I know this is not quite flat right now. Well, actually, it may be. It's one pin, and it is flat to the board. Now, this is where you got to be really careful not to touch any of the already installed surface mount parts with your soldering iron, because you will dislodge them, and you might not even know it because they're so small, and you might not have noticed you brushed against them. Okay, so I'm taking a look at how we're describing what we're doing here. Okay, we're just putting everything on the board. Again, we're not soldering anything yet. We will just be putting all the pots and switches and jacks on. And I think all the pots are the same. Oh, they're encoders. I'm sorry, they're not. They're encoding pots. Okay, good. And they all look like they're 10K. And they're all 10K, so we'll just go in as we normally would. 3 pins on the bottom. Let me show you. Where's my pointy thing? 3 pins here, which is our regular potentiometer pins. And then these 2 pins are for the click when you press the shaft, and then these are the support legs. Build guide says you may need to squidge the side brackets a little with snipe nose pliers to make them fit, and I certainly did that. Now we'll put all the jacks on the board. The only interesting thing here is, as you can see, on the ground pins, they kind of share. It's kind of a figure 8 or the number 8 for where the ground pins go, so they kind of share it, but not really, because there's enough space for each pin to be independent. So now we're going to put the switches on, and he does want us to put a hex nut on the bottom to support them, but I can't see. Oh, there they are. Now we'll set those little fellas in there. Now we'll put the spacer on the jacks, which is nice. That's a nice touch. I haven't seen, out of 140 kits, eurorack kits I've done on this channel, I have not seen this before. I like that quite a bit. Now we're going to take the LED board, and we're going to take the 2 little thingies I had mentioned before. Where'd they go? Where on earth did they get? Here they are. These little spacers. They should fit effortlessly, as the build guide says. And we don't want to bend pins, so we're just kind of putting them on, kind of like so. Now they are not snug, so I will have to be a little bit careful when I put them on. I'm just looking at the pictures to make sure we're doing it all right. I mean, it's pretty straightforward, but if you get that up, and that's what I thought might happen, because the spacers are not tight. One of them came off as I flipped it over, so we'll do it the other. And we can't really do it the other way, because if we do that, the switches will fall out. So we'll have to come up with a compromise here. I think we'll, of course, first I have to get the spacer back on here. take them both vertically, kind of like so. Oops, fell off again, and it went on the floor. It's always bad when something goes on my floor, because it's just, I have concrete and then a section of rug that my chair sits on, but it's very hard to see things when I drop them. Now we're making very sure that all the pins are aligned. Yep. Push that on down, and that is good. So that's the way that looks right now. Attach the LED windows to the front panel. Before you place the front panel, you need to attach the LED windows to it. That's what these are. Oh, they are translucent. Okay. So instead of having the raw LED brightness coming through, there's a little filtering in here. I gotta cut this plastic apart. Okay, so we are going to be putting this on this side because we want the more verbose side facing outward. And I'm going to give this a little check here, see what we will be doing. Looking through, the shine through. The wide margin points toward the label, wide margin. Not sure what he means by, oh, I'm not sure what that means. So that's 6 millimeters, and that's 5 millimeters, okay. Get my head in the shot. That'll look fine. Now I just want to let you know that if you mess this up, don't panic, because, well, this is going to make the LEDs look prettier. This is not technically, it wouldn't interfere with the operation of the device if you didn't get these on, or if you messed them up and had to take them out, or if you broke them. So don't worry about that. All that would mean is LEDs would be shining more brightly than you might want. So don't panic about this. And again, get my head in the shot. Making sure the potentiometers will fit through the holes with no problem. And in fact, I'm going to drop this on here before I go further. I'm going to get these two aligned. And yeah, they're very well clear. Everything's fine. Good. Okay, so that's that. And now we'll place the front panel on as I just did. So we'll put that on like so, and because it's got that spacer for the jacks, they all went on beautifully, and that stack looks really nice. And actually, you know, there's not he didn't give us any hex nuts for the other side of the switches, so we'll work on that once we get. What I'm going to do is solder the switches down, then adjust that hex nut in there so it kind of presses against firmly against the PC, the front panel when we're completely installed, and I can do that with a little, my pointy thing reaching in there and getting that where it needs to be. I won't mess with it now because it doesn't matter for assembly purposes. So what I'm going to do right at this second is get my handy dandy clamp from Wolfcraft that I picked up a set of them at Home Depot, and I'm holding everything together with that. And what I will be doing right now is I'm going to get some thicker solder, which I have tons of right now because I was doing a guitar amp, as I said. And I'm going to do support legs on this pot. And then I'm going to make sure that this jack is fully down, and there's a piece of foam that it can sit on to make sure that's fully down. And I will solder this in place. Now I will take one panel nut, for the one I just put on, snug that down. We get a panel nut for the jack I soldered. Get that down. Now I can get rid of the clamp because it's all going to hold together. And the next thing I'm going to do is just solder all these connections. So I will turn the cameras off for that because there's nothing much to see doing that. All the soldering is done, and I'm going to go ahead and do as I usually do and run my index card down here and just verify that I have soldered everything and nothing is bridged or shorted. All good. The only thing you really need to be concerned about is this support leg for the pot is right on, both of them are right on the connector, so you're going to smell melted plastic when you solder those. You could technically leave them unsoldered if you're uncomfortable with that, because they're just support legs, and if you do the other one you should be fine, but just be somewhat gentle with it. We'll put the rest of the panel nuts on. And there we go. All the panel nuts are on. Now be aware that because we have the spacer in here, we don't have as many threads coming through the panel on the jacks, and that spacer, it has to be in there because of this LED daughter board that we put in, so they had to make some sacrifices here, and we sacrificed a couple of threads coming through. So as I said, I'm going to spin these switch nuts up against the front panel and take my needle nose, or as the build guide and other countries would call them, snipe nose pliers, and snug that down against the back of the panel to give us a little security for the switch. That's good. Now switches work. We'll put our knobs on. And there we are, cat hair included. Knobs turn fine. Switches switch fine. Power cord can go in correctly, in the correct orientation. And that's it. That was the build. Pretty quick. Would be a good beginner kit. That's the front. That's the side. The back. the other side, the top, and the bottom. Now we'll give this thing a whirl. I think I'm going to use it in my little breakout box. I'm not going to put it in my main rack, but I may change my mind when I get things set up, because really we just want to look at the oscilloscope traces on this one. But I might do something else. So back in a little bit. As you can see, we're in the rack and up and running. I've got the scope up. The top line is the trigger input that I'm sending from this LFO. The middle line, the magenta line, is output A. The cyan line, the blue line on the bottom, light blue line on the bottom, is output B. So we're going to go through the various modes. Oh, I'm getting my arm in the way, of course. Let's start out with simply looking at this. If you look at this, it's only drawing 34, 35 milliamps, which is pretty good. On the negative rail, it's only drawing 15. So it's very power efficient. You could use this, and it peaked at 57 during startup, which is, I mean, look at the other peak, and 16 on the other one, which is very, very nice. You will not have any problem fitting this into your skiff. So let's go through what we're doing. So we're going to look at the 8 modes. First thing we're going to do is just describe the knob. And the main thing we have, actually the knob will be self-explanatory. Well, let's just go through it. So I'm going to start. Now you want to select your mode. And the first mode we're going to use is Bernoulli gate, which does a coin toss to determine whether you want to output the current trigger to A or B. Now to set a mode, you hold this for 2 seconds, and then you can see different colors on that outside ring. And we'll go to mode 1, and then click it in, and there we're fine. Now, as you may be able to see on the scope, even though the magenta line's not showing up all that well, I'm speeding up the LFO a little bit, you can see that for every pulse, yellow pulse coming in, it's all going out to A, because I've got it fully counterclockwise. Now when I go to the middle, I'm going to turn the sound up a little bit. Now when I go to the middle, you can see it's sending some of them to B. So it's either going to A or to B, and that could be interesting. Or we can go full to B, and because I don't have that plugged into the snare drum unit I'm using, you can't hear anything. But that's what the Bernoulli mode is doing. And then let's go to the next mode, which is clock divider. Oh, and the other thing is, generally, if you just click this fast once, it mutes it. And it'll mute all of these. So I'm going to mute all of them right now. Interesting, I can't tell whether millivolts went up or not. Sorry. So let's go to mode 2, which is clock divider. Now what this is doing, define how many incoming trigger events are required for one trigger output to occur on A or B. So it's going to allow us to, now it's completely matching. Every trigger input goes to the out. And then we can reduce it, divide it, so only some of the trigger outs go out. Oh, I want to do something else right now. I'm going to flip this over to wave, to pulse, so now it's a little more visible. But so the divider is going away from the A line, the magenta line, to a very distant, which is divider of 12. And the magenta line is not doing much of anything. I forget what this one does. I don't know what that does. Now we'll do a Turing mode. Go to mode 3, right there. Generates a random pattern. And the LEDs show the loop length. And we can make that bigger. When it's centered, it's 16 steps long. And then from center to 100%, it becomes gradually more likely that random steps will be added. Now I'm going to try something here because I don't know whether I'm stifling it by re-triggering it. Let me go back to here. So that's a nice little, I'm going to change the tone there just for fun. And that's fine. Now Euclidean split. Okay, so this is going to change us to, you can look this up, 2, 3, 4. Dividing the length of a 4 bar into 4 segments, resulting in a pattern of 4 quarter notes. Dividing it into 6 results in 2 groups of 3-3-2 patterns, the familiar clav rhythm. So let's see what we got here. That turned it down a bunch. I'm going to go back to just straight trigger there again. No, I'll change that back because we can absolutely see it better there. So that's Euclidean, and here's Euclidean Classic. Let me speed up the pattern a little bit. And then there's a bunch of rhythms. So how do I do that? Oh, so channel B is producing an inverse. And turning the knob sets different patterns. I'm actually not seeing an inverse on that. Oh, I see what's happening. So it's different patterns. That's nice. Let's mute that for a second. Now we'll do ramp and gate length. Ramp and re-trigger are special modes with the switch set to trigger mode. A trigger produces a whole sequence of timed output events. In gate mode, you can set how long the output is held high. So let's go ahead and do that. Go to 6. Unmute. I'm not sure what I'm supposed to be seeing here. I cut down the input a little bit. So obviously you can see A and B outputs are alternating. Oh, I had to be in trigger mode for this to actually work better. So you can see every trigger is generating a 16-step pattern. So that's interesting. Now we'll go to mode 7, which is somewhat like that, but not quite, because this is a re-trigger, so input trigger will produce a burst. So every trigger, as you can see, is producing a burst. And now I've shortened A but made B big. Now they should be equal. Now A is re-triggering more than B. So that's fun. And now we'll do pattern, and they have a number of curated patterns. In other words, they picked the ones they wanted. Not getting anything there. Let me do this faster. You can hear the different patterns that it has. So let's go all the way back to number 1. It's way too fast. Now I honestly don't know what M1 and M2 are for. Oh, DivSkip, those are 2 mutes, cayenne and orange, that each hold a mute setting for all 4 channels. Okay, so I could have this one and this one muted on M1, and then I switch over to 2, and I've got a different set muted, and I can switch between them. So that's very handy. I like that. And now we're going to do, with this running this way, I'm going to feed some CV in to the probability. Let me get a cable here. We'll go into probability here. Now you can hear it's changing. So that's fun. So that's basically it. I mean, obviously there's a lot more. If you played with this a lot, you'll find a ton of stuff that you can do. And I set it up over here because I wanted to do it with the drum, because this clearly is really oriented at drumming, which is cool. Let's re-trigger that faster. Let me switch over to that. And the CV is changing the probability a little bit. I'm going to pull that out and let it just be on its own. Ba-dum, bum, ba-dum, bum, ba-dum, bum, ba-dum, bum, 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 bum. So obviously, it's a very, very handy unit, and clearly there's a lot more than I've demonstrated here. I've just touched on the surface levels of things, but as you saw, it's a very quick kit to build. A little interestingness on putting the LEDs behind there with that glue strip, but that's all good. And again, just think about it. Theoretically, I mean, you could simply send a trigger in here and echo it out to both. So, and I haven't even done all the inputs. So this creates a lot of patterns. This is in some ways, I can see this as a whole drum machine. If you want snare, hi-hat, tom 1, tom 2, bass drum, or kick drum, another tom, shake or rattle, and something else. You could have 8 specific percussion outputs from this one device, and that would be pretty good. And again, another good one from DivKid and Making Sound Machines. And as always, I hope you enjoyed the video.